Hello and welcome to Objective-C programming course. This is lecture number 4. Okay, so in this lecture we're going to talk about design patterns and how common design solutions can help us build programs faster and solve our problems easier, and what design patterns are common in Objective-C and common to iOS and OS X programming in general. So those are the patterns that Apple gives us as something like a recommendation to follow. And then we are finally going to try a little bit of Cocoa, but that actually wouldn't be new because you, in lecture 2, already seen a simple Cocoa application, and we're going to follow on that and build another pretty simple application and see more concepts. Okay, first of all, here is one thing. We've made a simple adjustment to the syllabus, to the course flow. If you look at the syllabus, the version that you have, it will say today is core data lecture, but I've decided to move it a bit later to the course. So we're going to start with design patterns and Cocoa and follow on core data later. This is actually good news because core data isn't that easy, at least it's not that easy as Cocoa. But in fact, it's on the layer of, on the structure of OS X and all the layers of all those frameworks, it is lower than Cocoa. It's closer to Foundation. But we're going to follow on Foundation and Cocoa together and see how core data comes up later in lectures. First is the concept of a design pattern. And if you know this, it's really good. If you don't, this is a good start, because before you start building your applications, and if you were writing programs before, if you may be a good programmer, you write awesome algorithms and you can solve problems, and maybe you participated in a lot of Olympiads and programming competitions, or just was doing that for your own, then there is a high chance you never actually thought of a good design pattern. And I'm not saying it as a bad thing, I did neither, but this is something we should think about, at least consider today, because if you're writing an actual application, not just a program, a product that a user, a human being will be using, and another human being might be working on, developing on, and you will be developing on it later, then just getting everything into one pile as fast as possible probably wouldn't be the best idea. And the good idea would be to follow some design pattern, to think about how a program could be written in a nicer modular way so that you can build on top of it later easier. By definition, a design pattern in software engineering is a general reusable solution to a commonly occurring problem within a given context in a software design. And occurring problem, here's one thing. In English, there is this concept, there's word problem. And in Russian, there is a similar word, problema, and it's not exactly the same word, so it's not the correct translation. A problem in English usually means not a mistake, not something you have to kind of solve like in Russian. A problem might be a task, something to do. So in math books, you probably seen problem 10. And it's not like it's a problem to solve. It's just a task. It's something you have to work on. So when we talk about problems in software engineering, it's the same idea. It's some task, some area of work to be done. Following a good design pattern and choosing a good design pattern in the first place can speed up the development process by providing tested, proven development paradigms. A design pattern is not anything you can just take and use. It's not like a code, it's not a framework, it's not an application or a tool or a utility. It's just an idea. It's an idea on a piece of paper that tells you how to solve a problem. So you can go on, this is a new concept for you, go on to Wikipedia and type in design pattern software engineering and see the whole list of most commonly used design patterns. And probably the most influential and the most important, at least for our course, is MVC, Model View Controller. And this is the structure of it. So the idea of MVC is dividing your whole application. And when I say application, I don't just mean the program or the interface, not just the code, everything about your application. So if your application uses a database to get some information, that is the part of your application as well as the interface, as well as the code itself. So this whole thing, the whole product, your whole application is divided into three parts: model, the view, and the controller. This idea was developed by one of the guys who were working on the Smalltalk programming language. So as you remember, Objective-C has Smalltalk roots, kind of. It's much closer to the Smalltalk programming language than C++, even though both of them are considered to be object-oriented. In this case, in this matter, Smalltalk and Objective-C are much more object-oriented, and there are a few details in which you can see that. So Smalltalk is not around anymore, but it was really, really influential programming language. It was hugely popular. And one of the programmers of Smalltalk, and I won't try to pronounce his name, he's Norwegian, so it's sort of a Scandinavian tough name, but you can see it here. This guy invented MVC. So as you can see, MVC is really important for Apple, because Apple wants you to use MVC everywhere. It wants you to follow this design pattern. And it's historically connected to Smalltalk as well as Objective-C itself. So we really having a deep connection to Smalltalk. And this is good because it was an awesome language. You can see there is his homepage on the university server. I think it's the University of Oslo in Norway, I mean, where he teaches computer science. And his original image is here. The idea there is a user, which is for some reason a skeleton here, is working with the program, and his mental model is, for him, it looks like he's talking to the model itself, to the data of the application. But actually, everything goes through another layer, which is not really visible for him. This is not entirely true, as I explained. So let's see. What is a model? The model is the data and the logic. The author of MVC himself described it as knowledge. The model is the knowledge. It's everything your application knows and has. It's what data it holds and what operations, what computation is going on that data. For example, a contact in the address book would be a model. It should not be connected to the user itself. So the user should not be able to get to the model directly. But of course, he gets to the model through something else. And that something else is the view. The view is what user sees and interacts with. So this is really easy to understand because we were creating view in our second lecture. We were doing that web browser, and the first step we did is we just put all the UI, user interface elements on the screen. And we didn't write much logic, we didn't write much code. We just put those elements, and this is the view. This is what user sees and what user works with. It's all those buttons and interface in general. The thing that connects the view and the model is the controller. It's an intermediary between one or more of application's view objects and one or more of its model objects. So this is the bridge that connects model and controller. And what I just explained is the idea. It's really, really generic idea of MVC. There are more things to it. There is a special flow that says, well, you can talk this way and you cannot talk this way. I'm not going to touch it too much. But idea is pretty simple, and it's kind of logical. You would do that probably if you were writing a big application. At some point, you would come up with something like this. Here's the quick test. If your application is skinnable, if you can easily change how your application looks, it's probably following MVC in some way. If your application is really hard to skin, if you want to change the color of the buttons and in the interface and change everything, the positions and sizes, and you can do it easily and without touching the logic, without touching the data, it's probably MVC or some sort of dividing and making those abstract objects independent of one another. So that's MVC. We have a model, and if it changes, if some data changes or some computation is finished, so in the address book, let's say something happened and the address is changed and that address was on the screen, then the model notifies the controller and controller updates the view with this data. Then the view might have something that user can work with, maybe a button that says delete. And when user clicks that button, there's an event. It's a user action. That action goes to the controller, and controller does what it has to do with the model. In this case, it updates the model. It deletes the entry from our contact book. There are a few other design patterns and the ways to solve common problems that Apple provides us and recommends us to use and actually uses them itself in their own applications. One of the main concepts that we will touch briefly today, as you can see, I said this is a brief overview, so we're just going to go on this quickly, is delegation. And the idea is acting on behalf of another object. So you are an object. It's just like in real life. Sometimes you have a right to do something, your legal right, and you want to, for some time, give this right to another human. Or maybe you have a car and you want other person to use that car. So you both go to the attorney and you write this piece of paper. This is sort of delegation. Now that person can act on behalf of you with this car, and it can kind of represent you. It is limited. This is not forever, but for some task, there is a problem that you have to solve. Delegation helps. So delegation is a means for injecting application-specific behavior into the working of a framework class without having to actually subclass that class. So the frameworks are really generic. They don't know much about your application. And sometimes when you actually need to do something specific to your application, but you still want to use a framework, a good way around is delegation. Although you can avoid delegation at all in general and just create your own subclasses of all the framework classes you need and write everything in there. When class delegates some properties to another class, he would first of all define the property to hold a reference to that delegate, hold a reference to the object which takes responsibility of some actions, and then define a protocol. And that protocol should be something the delegate class should adopt. And this brings us to protocols again. You remember protocols, right? In the last lecture, the protocol is just a list of methods that is shared between multiple classes. And this is another design pattern. This is another way of solving problems in Objective-C. And good thing that we have protocols, because it actually allows us to establish communication between objects that are really unrelated by inheritance. And inheritance is not just a lot of computation, but also a lot of code to write. And a protocol is easier and faster. So sometimes you have a lot of the classes, and you just don't want to mess with this inheritance business and the whole object-oriented thing. But it's quite easy to write the protocol, and then two classes adopt that protocol, and suddenly they become sort of related. They become classes of common language. So protocols is a good thing, and if your project becomes large enough, and you're thinking, well, I have to inherit this class and I have to create multiple subclasses to have all this thing, think maybe you better work with protocols. Another idea that is highly popular in Objective-C and OS X and iOS is notification center. The idea is you have multiple objects and you want them to react to some event. And simplest way to do is, the most obvious way to do and the most probably stupid way to do it is, well, get those objects somewhere, get all the references to those objects, and put the call to those objects to the place where that event happens. So let's say user click the button and you want to update multiple objects when user clicks the button. And you would put a code to call all of those objects in the click button method. But this is stupid, because now you have another button and you want to do the same, you write it all again. And in general, if you want to add more objects to React or delete some objects, there's just too much to do. A notification center is a subsystem that helps in this matter. It's a subsystem of the Foundation framework that broadcasts a message, a notification in this example, to all objects in the app that are registered observers of an event. So all you have to do is say this object is the observer of, let's say, user click event. And every time user clicks an event, it's automatic. A notification center seamlessly, without you knowing, gets that user click that and sends a notification to that object, and that object can react. So all you have to do is register that object as an observer and write the actual code on how to react. This is really good. This helps a lot. Okay. This notification center, notifications that those messages that were passed through notification center are quite similar to delegation messages, because both are sent to any object when certain events occur. However, methods that handle notifications, unlike delegation methods, cannot return a value. So those notifications are only one way. So the object that issues that notification, issues the event, doesn't know much about what objects receive those notifications and what they do with that notifications. This is just one-way broadcast. It's like radio. When radio station broadcasts the message, you can hear it or you cannot, but the radio station doesn't really know. They just broadcast the message out there to the world. Another idea that is used a lot is the key value observing, or sometimes they call it just KVO. By the way, there's one thing I just wanted to share. I always thought that these things called abbreviations. So if you have KVO, it's an abbreviation, and the whole thing is key value observing. But it's not actually an abbreviation. An abbreviation is if it's a word, if you can pronounce it as a word. So if it was quo, like you say with scuba or NATO, that's an abbreviation if you pronounce it as a word. But if you pronounce specific letters, like in this example, you say KVO or TNT, that's initialization. Oh, I forgot. It's not initialization. Yeah, that was a fail. Okay, anyway, a KVO is a way to for an object to observe a property of another object. So it's sort of like notification, but the idea is the observing object is notified when some property of another object changes. And it learns about the old value and the new value. So let's say I have again, in my view, some radio button. And when users select that button, I want to react in some way. So yes, I can just register it as an event that when user clicks, I check the value. But the idea is having this whole thing being abstract, having this whole thing as this pattern of observing keys. So when this happens, I am, as an observing object, know what it was before, and I know the new value, and I can react upon this, because sometimes not only the new value matters, but what it changed from. Okay, so that's mostly, this is really boring and theoretical material, but we have to have it there. Let's move on to Cocoa. So Cocoa is exactly what you think, the word itself. In Russian we call it cacao, and in some languages it's actually, but it's the same word. As you remember, okay, yeah, by the way, how we proceed from here. We still have something in Foundation framework that we didn't cover. So there are still things like working with objects and memory, but I thought we should really go on to Cocoa, to actually graphics as fast as possible, and then cover some Foundation stuff as we go, because, well, this is just getting boring, right? I want graphical applications. I want programs that you can write and actually use, not just print fractions. So we will learn the rest of Foundation as we go, and we will move on to core data in the following weeks when we become confident with Cocoa and Foundation. So we see how we go. I will try to reflect the actual progress of the class. So, as you remember, Cocoa is the top level thing. So the top level framework was called AppKit. It's the framework that is responsible for all the graphics that we see. It's all those windows and buttons and labels and text fields and some of the media. It's that thing that is most close to the user. It's what we actually work with. And the Cocoa is the API to work with it. It's the way to use the AppKit. And before we start, I want to tell you a little bit of history of how we get there. So there was that guy, you probably heard of them, Steve Jobs and Steve Wozniak, and they were just guys that were trying to build their own computer. So they opened a small company in the garage, and you can see the picture in there, and they were creating computers. So the company, as you know, became quite big, and when it became really big and really successful, at some point it happened that Steve Jobs was fired by Apple because he wasn't the sole owner, and at some point they decided he is quite dangerous. And the story itself is quite controversial, and I'm not sure what to make of it. If you are interested, there is a movie, if you haven't seen it, Pirates of Silicon Valley. And that movie is quite short, but it tells you a story of basically Apple, Steve Jobs. There are plenty of books, and I think there's another movie coming up because Steve Jobs died and he's such an iconic figure. But anyway, he was fired, but he still wanted to make computers. He still wanted to make awesome stuff. So he opened another company called Next. And he hired a lot of really talented engineers and programmers, and they were making this computer called Next. They also started making their own programs and operating system called Next as well. And you probably never heard of it because it wasn't really widely popular. There was an Apple computer produced by Apple at that point, and there was IBM computers and just PCs everywhere. But Next computers were really popular in small groups like scientists, engineers, specific professionals. And an example of that is Tim Berners-Lee, the guy who invented the web. So here you can see the first web server on this planet. And this is the computer of Tim Berners-Lee at CERN. CERN is that company, of course, a scientific organization, international scientific organization that is responsible for a Large Hadron Collider. So they basically created the internet as we know it today. They didn't really create the internet, but they created the web, the web browser and HTTP and stuff like this. So this is the first server. You can see it says this machine is a server, do not power down, because it was the first web server. And this is a Next computer. Not only the hardware is from Next company, but the software is also. So one of the first versions of Next operating system looked like this. And yeah, it's kind of ugly, but you have to understand this was awesome. This was fantastic, really, really ahead of the time, like 5 years ahead of the time. And yes, it wasn't really new. It wasn't completely their idea, and most of the stuff here is from unknown, really, operating system and systems in general, and technologies from Xerox. But the fact is a fact. There was an operating system built in a company that founded by Steve Jobs, and it was really, really good. So they built this operating system, and they built it on top of Unix. So they followed the Unix pattern, and they used a lot of Unix code, and they built their own kind of core and the kernel, and released it as by the name of Darwin. And you can still get that Darwin kernel for free. They followed many things of Unix, not Unix itself, but BSD, the kind of close relative to Unix from California. So they all from California. And it was quite stable and quite professional. The way they decided to go on with the graphics was the same as in Unix. They decided to create not to include the graphics into the kernel of the operating system, but to have it as a X server, as a graphics server outside the operating system. So in this way, graphics and everything you see on the screen is not highly connected to the kernel, and if it crashes, the kernel is fine, the operating system is fine. So at some point, Next Step was renamed to OpenStep, and then it became Cocoa. It became the top layer of Apple operating system because it was so popular. The Next Step and Next computers and Next software, as it was called later, Apple bought it, and this way Steve Jobs went back to Apple. So this is all fine. Let's actually try something. Let's create another application like we did with the browser, but this way we will actually write some code, because the browser was fine and was quite powerful because it's a web browser. Come on, we did it in 5 minutes, but we didn't write much code. We just connected the buttons. So I want to create a simple random generator. And here, as you can see, we can select use core data. Yeah, I hope you've seen that. I selected the Cocoa application, not the command line application. So I can check use core data, but we're not quite there yet. So I just go next and save it in the same place I usually save it. And my computer really needs more memory because it's dying. Okay. So what I want to do is to have a simple window with 2 buttons. First of them will generate a random number and show it on the screen. Second will seed the random generator with a random, quite not really random, but sort of random number taken from the time. And I go on to my zip file, and zip is the file that defines my graphics, my window, and everything user actually sees. So I select window, I see my window, random generator. So zip is actually an XML file. It's a textual representation of all the elements. And when it's compiled, it is converted to a nib file. And we're going to see how that helps us. So I don't need much in this time, so I don't need to connect any new framework. I will just use those that are built in. So I need 2 buttons. I'll take a push button here. I need another button here. And I need a text field. So I can easily find it here if I start. Yeah, I'll just take a label. A label is something that you cannot change, you cannot type in, but you can change, of course. So I will make it centered right there. And yeah, this one will be generate. This will generate a new number, and this one will be seed. This will seed the random generator, and this will be by default 0. I don't need that much of a window. That's fine. This is an ugly application though. Okay, so that's cool, but this is the view. We don't have any logic. We need to create a class, and let's create a new class. I will add a new file. I will choose Objective-C class, and we'll call it rand. I will inherit from NS object as usual because that's really useful. We'll save it in the same folder of my project. And here I have 2 files, the header file, of course, and the M file, the implementation. So here I need, first of all, to define a variable that will represent my text field, not actually text field, the label. So I need to add a new variable, and it's a text field, so it will be NS text field, and it's an object, so I need to make it a pointer. We'll call it text field. But the thing is, to make it, because I want this to represent the text field I have in the interface, the label I just created. For this, I have to make it an IB outlet. An IB outlet is not really a type of data, it is a macros. And that thing tells Objective-C that I'm going to use this thing to represent something from the interface. And IB stands for Interface Builder. Before Xcode 4 that we are using, the Interface Builder was a separate program. It was a separate window that we were using to create the interface. Now we just have it here. But all the naming conventions are still there, so we have IB outlet. Okay. I want to have 2 functions, one to generate random number and second is to seed the generator. So just like with IB outlet, I have to say that this will be a function that is going to be connected to the interface, to something in my visual side. So I will make it an IB action. And I will call first one seed, and yes, I need a sender. The sender will be the object that I connect it to. So if I make the seed button to call this function, then inside the function I will be able to refer to that button by this variable, sender. And I need the same thing for generator. So I'll make it generate and sender. Okay. So I have the interface, I have everything I need. Not quite there yet, but at least I have something to work with. So I come back to my interface, and here you can see different things on the side, on the bar. If you remember in the example with the web browser, we could control click on any element and have this line and connect it to some other element. Not all the elements in your program are there. Not all the elements are visible. So an element like your class that you just created is not visible. It's not part of the interface. So I want to still be able to connect to it. I don't have to do it visually. I can write it all in code, but why not take advantage of something really useful? So I want my class to be here because this is the part where all the invisible parts of your program are located. So for this, I will add an object. I'll look for the object here. I have this cube, and I will just drag it here. So this now can represent any object. And if I go to my utility area here, to this third tab, I can select a class which I'm going to use. So I want to use my rand class and just type it here. Now this is the rand class. Now I want to make some connections. I want first of all to connect the label to the class, to the object. I want this thing to represent my text field. For this, I will right click and I have outlets here, text fields. I can take it and connect to my label. So now we see the connection. The text field variable is connected to the object in my interface. Now I want to make some connections other way. I want this button to call a method in my class. So I will control click and drag, have this line point to my rand, and this is generate. So I select generate and do the same with the seed. This will make the seed call. Okay, I'll save just in case, and now it's time to write the actual code. So first I want to write the generator. So generate, let's create an integer number. I will make it first of all typecast to integer because this will be a float, I think, to use the function called random and create a random number from 0 to 99, but yeah, I want it from 1 to 100, so I'll just +1. So nothing new here, you probably did the same with the random in your project, but now I want to call my text field. So since we connected the text field variable to the text field in our interface, I can do stuff like this. I can say text field and set integer value and pass my number. All right. So another method to implement is generator. Oh, I'm sorry, seed. And seed will take the current time and seed it to the random generator, because, well, we don't really have random generator. We only have pseudo-random, and it takes some input because it has to take some input. This is how computers work. So one of the easiest way to kind of create a random seed is take current time, because, well, it's different. It's different all the time. We're not sure what time will be. So let's call as random and give it an, first of all, typecast to unsigned. Take the time, take the full time, so it will be null. And yep. And let's actually change the text field to and say something like, this is not an integer, I want to set the text, so I'll be passing in a string, so I can say set string value and make it something like seed generated. Okay, if I run my code now, I can click Command R. I will hopefully see my window here and can say generate. We can see it makes the random number, and if I click seed, we have seed generated and go on with random numbers. That was lucky. 2 times it was 1. Okay, this is basically how it works. You have a view, you create your interface, you can just work on the interface completely separate, and then you connect it with the code. What it gives you is not only the ability to skin your applications and just have it separately, it gives you an ability to work in really flexible teams. Let's say you have a designer, and the designer thinks about how your application will look like, how your interface will look like. He can work completely separate of you, and he can actually work in the same Xcode, even though he's a designer and he doesn't know, or she doesn't know, programming languages. They can just work on the design, on the interface, and build everything they want, put all the media they want, and then give it to you, and you go on with the code. This is really powerful. This gives you a lot of time saving. Okay, let's add another thing. As I said, the zip file, the XIB file, is the XML representation of your interface. And when we compile it into the actual window, the actual interface, it will be a nib file. So when this nib file loads, it puts all the elements there. We say it wakes up. And we can have some things to start when the interface is awakened, when interface started up. For this, we have a method called awake from nib, and it's a void method. It doesn't return anything, and we have it here, awake from nib. And let's see, I want to put the current date onto the label because 0 is not really nice. So I have ns date. Make it now. Actually take the date of ns date. And now this, yeah, it's case sensitive, of course. This ns date now pointer is a pointer to the object. So it's not a string, although it will understand it as a string, but in this case, I want to set the text field, but set object value. And remember, in the last lecture, we were changing the description method of an object, of a class. This is what's used here. So if I just take now, that would be just the string of the current date. And if I run my application now, hopefully I will see the current date. Yes, it says Thursday, September 20th. I'm making this lecture on the same week as lecture 3. So this works. There are a lot of the things you can change on your interface without looking into code. For example, I want this button to be disabled, and I could just put it here. In awake from nib, I can make the button disabled, but there's an easy way. I can just select it here and go to my settings. I'm really still here. I can just make it disabled, and I can even add sounds and different things to it. I'll make it have some sound here, and I'll make this have some other sound. So the idea is I want this button to become available only when I click seed. So in seed, I can access that button, but I don't have it yet. So just like I did with the label, I need to reference to it first. So here I will add an IB outlet, and this is NS button, and I'll make it a gen button because this is a generate button. I want to connect it here, so I go to my interface builder, right click, and I have a new reference outlet to generate. Yep, I won't let me select. Come on. No, that wasn't the thing. Yeah, I want the gen button here, outlets, and connect it to my generate button. So now generate button is accessible through the code. And in the seed code, after I created the seed, I can reference the gen button and make it set enabled to yes. Let's see how it runs. It's disabled. I can't click it. If I hit seed, I have a sound. Hopefully you hear it. And generate has another sound. So that was easy. Okay, I hope you get the idea. This is quite simple. Yes, your applications and your projects will be much more complicated, but this is a good start, I think. Okay. I will talk about debugging, but probably not now because we don't quite have time. I want to talk a little bit about your project. Assignment 1, the project 1, is due next week on October 3rd, and this is the day when assignment 2 will be issued. And all the next projects, assignment 2, 3, and 4, will be a single application you'll be working on, and those would be individual applications. So for assignment 2, you will have to decide what program you want to create. And you, of course, have to consider the time you have and the accessibility of the Apple Lab in the university you have. So just think of what application you want to have. Maybe you want to write some small program for something. And you will work on that during all the projects 2, 3, and 4 and submit it as your final application. Hopefully there will be something useful. All right, that's it. Thank you and see you again.